Hello my dear students, I am Arindam Chakravarti, Faculty of Mechanical Engineering. Today I will be learning about beams and what are its support as well as the conventions we have in beam. Number one, what we have to first learn is types of support. Support are of three types. One is hinge, H-I-N-G, hinge. Number two, roller. Number three is fixed, or sometimes we also tell us fixed. That depends on our pronunciation. Hinge, or this is also termed as pin. Now, how does it look? For example, you need to remember that how does it look so that you can understand that is a hinge support or pin support. Hinge support looks like this, or it may look like this. In roller, the thing comes like this, and there is some balls down it. As well as similar for this one. This is a triangle, and there is a ball down there. And for fixed, it is nothing but a beam is fixed with the body. Now try to understand. We came to understand about hinge, pin, roller, and fixed support. Now, where and how the reaction comes and what are the reactions we can see. For hinge, we can see two reactions. Hinge have two reactions. How it works, let us understand. This is how. This is for Ry and this is Rx. And for roller, the roller support is having only one reaction, Ry. And for fixed, we have actually three reactions. Let us go with this one, this diagram itself. So it happens like this: Ry, again Rx, and a moment which is working N. Now try to understand that we know that there are types of hinges and everything, but what about the load? What are the load which will be executed on the beam? There are actually three types of load to get in very small or in a precise way to say three types of load. One is simply supported load, one is UDL, another is VDL. UDL means universal distributed load, and VDL means variable distributed load. Now let me write and let me show you. Point load, P-O-I-N-T, point load. Let me change the color. Point load. If a beam is subjected to a single load with a single load in a single point, is termed as point load. Another one is UDL, uniformly distributed load, or it is also termed in some places it is also termed named as universal distributed load. The name can be different, but the work is same. Now what happened is that the load happens to be in a section. Let me consider a section A, B, and the length of the section is L, and the width of the section is W. Now the load is P per L. Now how you can change it to a point load? Now here comes one point. So why do I need to change it to a point load if I have a UDL, that is uniformly distributed load? Why do I need to change it? The main reason is we cannot calculate this way. We cannot calculate this way the load, because someone may calculate in 5 points and one may calculate in several points, in more than 10 points, more than 1000 points also. So that becomes most critical point, and where we cannot calculate in a linear way. So to make it linear and understandable, what I can do is I can change it to a point load. What I can do? I can change to point load. How to do that? Very simple. Just this is your point A, B. This is the load, and from here to here, this will be L by 2 and this is L by 2. Now the length over here is P into, okay, P into, now try to understand what would be the load. For making you understand about this one, you need to understand the area of it. The area of triangle. Area of triangle. What is the area of triangle? Area of triangle is length into breadth. So the length is nothing but the L and the breadth is P per L. So what you can do? P into L. This is nothing but the actual magnitude of load which will be acting on the center between A and B. Now here comes one more twist. If it is so, what about UVL? That is termed as uniformly varying load, or it is also termed as VDL, that is varying distributed load. What will happen on that case? On that case, it looks like this one. Let me change the color. It looks like this one, where the load is not same throughout the section. That means here the load intensity is maximum and the load intensity over at the point A is minimum. Let me consider this to be a length L and this load to be P per L. Now try to understand how to change it to a point load. Let me write in a short way, point load. The simplest way to do is this: A, B, make a load over here. Just remember area of triangle. What is area of triangle? Area of triangle is half length into base. What is the length? L, and what is the base? P per L. So what I can write is L into P slash L. L. Now, what would be the point where the load will be acting? The most important part is that the load will be acting on the centroid of the triangle. What is the center of the triangle? That would be L by 3, and that would be 2L by 3. Last point of this topic is nothing about the conventions. We have learnt about the load, we have learnt about the support, and lastly, what are the conventions? The conventions is for SFD, full form is shear force diagram. Shear force diagram. Force diagram. The convention stays like this. Okay, positive, negative, negative, positive. So what does this mean? This means that if you are calculating from the left hand side, if you are calculating from the left to right, that means you are calculating from left to right. That means you will be using this one. This section, this complete section is for left, and this complete section is for right. That means if you are calculating from the beam from left to right side, you have to consider this zone, because this zone will help you understand how the shear force is acting on that point. Similarly, if you are calculating from the right side, that means from this side, this will actually help to understand which will be positive and which will be negative. Now let me get to the next point, and the last point is your sagging hogging. The most interesting part of this convention is about the movement, or we can say sagging and hogging. How it works actually. That is termed as BMD. That is bending moment diagram. So bending moment diagram is nothing but a bowl and a bowl which is inverted. Now this is for left side, this is for right side. That means any moment at clockwise from the left side will be positive, and any moment anti-clockwise will be negative. Now vice versa, if any moment from the right side anti-clockwise will be positive, and any moment from the left side, any clockwise moment from the left side will be negative. These are all the concepts which will help you to understand beam in last minute edition. So if you have any queries, let me know. Thank you and have a nice day.